You can raise a single binomial to a power using Pascal's triangle. This is called Pascal's triangle over here. Pascal's triangle is formed by lining the border with ones and placing the sum of the coefficients beneath the two original numbers. So there's different ways that you can develop the Pascal's triangle. One, start with 1. Then underneath it, since you're bordering it with ones, notice how 1 plus 1 is 2, so that goes right underneath 1 plus 1. 1 plus 2 is 3. 2 plus 1 is 3 underneath here. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And you keep going. Okay, so that's pretty neat, and you can use it to expand a binomial. So remember, a binomial is 2 terms of a polynomial, and you're going to use the row that has 5 with its second number that's raised to the 5th. So you go down to where is 5, right here. And then what you can do is notice how these are all the coefficients: 1, 5, 10, 10, 5, 1, 1, 5, 10, 10, 5, 1. And notice that the first exponent, so if you're doing A plus B, you're going to go A5, B0, A4, B1. The exponents of A and B always add up to 5. A exponents decrease, B exponents increase. So number 1 down here, use Pascal's triangle to expand A plus B to the 7th. So it would be nuts to write out A plus B, A plus B, A plus B, A plus B in FOIL, and then do distributive property over and over again. Instead, what I'm going to do is I'm going to go to the 7th one with a 7, and I'm going to do A to the 7th, B to the 0. The coefficient of that is 1, plus 7, A to the 6, B to the 1. Notice how my A is going down and my B is going up. Plus 21, A5B squared, plus 35, A4B cubed, plus, second 35, plus 35, A3B4, so it's all just about the pattern here, plus 21, A2B 5, plus 7, A B6, and then ending with plus A to the 0, B to the 7. So really in this first term, I don't need to put B to the 0, because that's just 1. So that's your final answer. And then when you're doing one with, when you're doing it without variables, you just need to be really careful with your negatives. So I'll show you how to do that. So I'm going to go to the 4th row, look up here, right there. And so I'm going to do x to the 4th times negative 2 to the 0. So that just cancels out, just to be x to the 4th. Then I'm looking at my line right here, and I got the next coefficient is 4, so it's 4 times x to the 3rd, and then my b, or my negative 2 to the 1st, plus my next coefficient is 6, x squared, and then negative 2 to the 2nd. Notice how I'm putting the negatives in parentheses here, and at the end I'm going to simplify it. So plus 4x to the 1st, and then negative 2 cubed. And I'm going to end with 1 times negative 2 to the 4th, because the x to the 0 just cancels out. Then what you want to do is you want to simplify it. So this is going to be x to the 4th. I have negative 2 times 4, so it's negative 8x cubed. I have 4 times 6, so that's plus 24x squared. I have negative 8 times 4, so that's negative 32x. And at the end, I have plus 16. Okay, C, find the second term of x plus 3 to the 9th. So let's see if I have 9 down here. I don't have the row of 9, so I'm going to add the row of 9. So it's 1, 9, 36, but I don't need that because I just need the second term. So the second term, I'm going to start out with 9. So I'm going to write 9. Should have just done that anyway, but I showed you how to do it on the triangle. And then this is going to be x to the 8th power. And this is going to be, remember our exponents have to add up to 9, so it's going to be times 3 to the 1st power. So now this is going to actually be 3 times 9 is 27, x to the 8th is going to be the second term. Okay, number 2 is very similar to what I did in the previous page, so I'm going to take one that looks a little more complicated. This one right here. So I'm going to go down to this one right here. So it's going to be 1. Now I always put these expressions in parentheses right here, and then times, excuse me, negative 3y to the 0, and that just cancels out, plus my coefficient is 5. So it's going to be 2x to the 4th power, and then negative 3y to the 1st power, because remember these powers need to add up to 5. My next coefficient is 10, so it's 10. These are my coefficients so far. And it's going to be 2x to the 3rd power times negative 3y to the 2nd power plus another 10. It's my coefficient up here. And then 2x to the 2nd power, and then negative 3y to the 3rd, plus a couple more terms, running out of room, plus 5, and then 2x to the 1st power times negative 3y to the 4th. And the last one, you have 2x to the 0 power, but that cancels out. So it's going to be times 1, and it's going to be negative 3y to the 5th power. So at the end, you have the ugly job of cleaning all this up and just being very careful with your exponents. I wish I had more room here. So I'm going to try to do it above it in blue. So this is 2x to the 5th. So this is just going to be, but remember, you're actually taking 2 to the 5th power too, so it's going to be 32x to the 5th. Then your second term, you have 2 to the 4th, which is 16, times negative 3. So 16 times negative 3, and then you're multiplying that by 5. So this actually is going to be a negative 240 x to the 4th y. That one's done. Then in this third term, you have 2 cubed. 2 cubed times 9, and then times 10. So this will be plus 720 x 3y squared. Done. This next one, you have to square 2 and then cube negative 3 and multiply that by 10. So it's going to be 4 times negative 27 times 10, which is negative 1080. That's going to be x squared y cubed. And then this next term, did that one. This next one, you have negative 3 to the 4th, which is 81 times 2 times 5. So this is 810 x y to the 4th. And then the last one, you got negative 3 to the 5th, negative 243. So just take your time. Make sure that you're just going slow and using the pattern. Find the 4th term of the expression x plus 2 to the 20th power. Okay, and then we get to one where you can't really use the awesome Pascal's triangle. I mean, you could write out the first 20 rows, but it would be a lot of work. So the binomial theorem is that if you have a plus b to the n power and you expand it, this can be written as the first term would be n choose 0 times a to the n. The second term would be n choose 1 times a to the n minus 1 times b. So don't get confused on this notation because this is, if this was a to the 10th, this would just be it's going down. So this would be a to the 9th. And then b now is starting up. So right here, b would actually be 0. We don't need b to the 0 power. We don't write that in because that's just 1. And now b is to the first power. So the next one, the pattern is going to be n choose 2. So then the power is going to be a to the n minus 2, right, times b to the second, because that's going up. And then all the way to the last term, which is going to be dot, 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 plus n choose n, remember, times a, actually, I don't want to do a because I was going to write a to the 0, but I don't need to write a to the 0. So I'm going to write b to the 1 because a to the 0 just cancel out. Or b to the n, oops. So if you're going to try to find the 20th term, I would definitely use the binomial theorem. So it's going to be, you're trying to find the 4th term, so it's going to be 20, choose 4, a, or x in this case, to the 20 minus 4 powers. So this is going to be x to the 16th power. And then y, remember these two have to add up to 20, y to the 4th. So I need to do 20 choose 4. So I'm going to use my calculator, and I'm going to do 20 choose 4. So I do 20 math probability, choose 4. It's 485. Okay, that would be ridiculous to use Pascal's triangle with that. So it's 485, x to the 16th, y to the 4th. So the cool thing about this is actually I probably should have done should have been probably easier to do the binomial theorem to do this. I didn't read correctly. I was just still thinking of the Pascal's triangle since it was written out over here. It's just neat how they go hand in hand. At least I think it's neat. So that's where we're getting these numbers from on the Pascal's triangle is from the binomial theorem.